So the answer to the group work part of it, A is 251.7 kilometers per hour, and B is 61.7 kilometers per hour. Knowing that on this one you have to use 30 divided by 1,000 because it's in kilometers, not in meters. Okay, so let's talk about the graphs. And I do have a class here that if they have questions, they'll ask questions along the way as well. Okay, so let's start with this one. The important thing is you have a starting point for both of these, whether it's an even index or an odd. The even index one, it's actually the starting point. This one, it's the turning point. You start there, but it makes it the graph turn directions. So for this one, what will make the key idea here for the starting point is what will make the inside equal to 0. So starting point, you're used to it being the opposite of the number, when in reality, it's what will make that, put in for x, that will make it equal to 0. So that's a 4. And then the same number is out there, would be a 1. So I'm going to start my graph at 4, 1 up here. Now, on this, when I'm going to do a table, I'm going to have my table, put my 4, 1. This is critical, it's new. I don't think you've seen this before. But if I have a negative on the inside, notice it's not x minus 4, it's 4 minus x. When you graph it, you'll notice it goes in the opposite direction. That turns it to the other part of the domain. So this graph is going to go in this direction. If you put a negative in front, there's a negative in front where this 3 is, that would flip it over. So instead of being a parabola going like this, it would flip it to the bottom half if it's a negative in front. So notice those two differences. So I'm going to go to my calculator. I'm going to enter this in. So we get, clear this off, and I'm going to put 3 times square root of 4 minus x, in the parentheses, plus 1. It's probably a good idea, you might have been using your calculator for physics or for other math problems, to just go to Zoom Standard, just to get a standard look at the graph. So hit Zoom, go down to Standard, and here's what the graph looks like, starting at that point and going up. Now we want a few more points, right? Am I going to make this a solid or a dotted graph? I'm going to make it dotted. And folks, this is important, okay? This is something that's kind of new, is this starting point should be an open dot. Okay, think about it. That point there, if I put in 4, 1 into this equation, is 1 less than 3 times 0 plus 1? Is 1 less than 1? The answer is no. So technically the starting point needs to be open when we have that less than or a greater than inequality. So to go with the dotted, put an open dot. Okay? Now let's put some other points from the table. So you go to second table, and notice I get errors above 4 because it's not in the domain. And so I'll go with, let's see, 3, 4. You don't have to do a lot of points. Let's give something a little bit further away. Let's maybe go with 0 and B. So let's go to 0 and C. That gives me 6.2. These points just give a shape to it. That's why you got to give some of the ordered pairs. So 3, 4, 0, 6.2, right about there. And so I'm going to go a dotted graph. Don't have to do a lot of points. There we go. Now, here's kind of a quick, here's something that I've asked you to test a point. Is 0, 0 a point I can test? No. I can in this one because it's in the domain. It's covered over it. So I can use 0, 0. So I'm going to test 0, 0 just to see if it works. And then I'll give you a summary of how to make it quicker if you want to. So if you put in this, you get 3 times the square root of 4 minus 0. So it's 3 times 2 plus 1. Is 3 times 2 plus 1 0 less than that? The answer is yes. So this works. So I'm going to shade below it. Now folks, here's kind of a quicker way to do it. Because we always have the y by itself, this is y less than this. If it's a less than, it's going to be below. If it's a greater than, it's going to be above. You know, so you can take a little bit of a shortcut on that. Now on this, I do want to add one more thing. Remember we talked about having to close off the region for the domain. You can't put in values more than 4. They're not allowed. If you put in 5 into that for x, it's not allowed. So you have to, when it's going down below, you have to close off that region by putting a solid line down there. It's always solid. Doesn't matter whether it's a less than, greater than or equal to, less than or equal to. Because if you put in one of these values, 4 comma negative 5, is negative 5 less than 3 times 0 plus 1? And the answer is yes. It works on every point on that edge of the region. Okay, so don't forget open dot when it's not or equal to on our when we've got our starting point, and then draw this line here as part of it. Okay, let's do the next one. So on this one, you've got we're going to have our starting point here. It's actually a turning point. Is going to be what do you put in for x to make it 0? That's 6 comma negative 3. So I'm going to put that on here. 6, negative 3, 1, 2, 3. Let's enter that on to the calculator. Put that in here. So y equals, we'll clear this one off. Okay, we're going to do 4 times the cube root. Cube root's found under the math menu. Down to cube root. And we'll do x minus 6. So x minus 6, and then minus 3. Here's what the graph looks like. Those numbers in front, like this 4, really makes it go up fast. If you had a fraction, it would make it go up slow. It'd be almost like a horizontal line. All right, so now let's go ahead and make a table. Put 6, negative 3 in the middle for an odd one. So we're going to come up with values above and below it. So second table. And let's see, I've got 6, negative 3. I'll do 5, negative 7. Let me get something a little bit lower than that. So let's go with let's go see what 0 gives us. Okay, so 0. Up here, 0 at negative 10.3, and let's go above this, so let's get some values above 6. So there's 7, 1, and let's do 10, 3.3. 7, 1, 10, 3.3. Let's plot those. It's going to be solid, because, it's going to be dotted because we've got just a greater than. So we need to make this an open dot when I plot the 6, negative 3. So open dot. 0, negative 10.3 down here. 5, negative 7 down here. We got 7, 1. And 10, 3.3. Right up there. So it's going to come in, dotted line. Here's my dotted graph. Okay? This tells me it's going to probably be above. I can test 0, 0. Is 0 greater than 0 minus 3? And it is. So I can shade above it like this. Above this graph. Okay? So if I did do a test, 0, 0. Any questions on the graphs that you guys have? Anything you need questions on? Okay. All right, let's turn over to the other side. We're gonna skip the problem at the top here. We're gonna go down to number 5, 6, 7, and 8. So we did these. When you have the same index, you can multiply the numbers underneath, okay? Same index, you're gonna have cube root of 5 times 1 times 25 is 125. X to the 4th, x squared, x to the 3rd, that would be 4 plus 2 plus 3 will give me 9. Okay, now I'm gonna separate it. So I did the numbers, and I did the x's, brought them all under the cube root because of that, okay? Thanks. Now, I'm gonna separate into the cube root of 125, and the x's I usually make into a exponent. I do, this is my preference, you can do it either way. I like to leave the numbers underneath. I like to put the exponents on the variables, so 9/3, 9 over 3. Now, if you don't have your perfect cubes known, you just create a little table for yourself. 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is equal to 125. So you're looking for these numbers under the cube root. 125 would be 5, this is just x to the 3rd. So you've got your final answer there, simplified. Problem like this, you need to FOIL it out. Make sure you recognize when it's a plus or a minus, you've got to do the double distribute. So 5 times square root of 3 times 5 times square root of 3 is 25 square roots of 9. Minus 30 square roots of 3. Plus 30 square roots of 3. And then minus 36. 25 times 3 here, these cancel, minus 36. So 75 minus 36, that gives me, let's see, that would be 39, I believe, for an answer. So any questions on that one? Okay, double distribute, multiply it through, simplify. Let me move it. Okay. Now this one you got to recognize, folks. I'm gonna do a preface on if there's only one term in it. Like if you had 7 over the square root of 3. This is a different problem, folks. Not the same problem. It's a different problem. If you had something like this, you just multiply by the square root of 3 over square root of 3. To get rid of the square root in the denominator. Radicals can't stay in the denominator. So you get 7 square roots of 3 over square root of 9, which is equal to 7 square roots of 3 over 3. But when you have a binomial, you've got to multiply by the conjugate. That's going to be what gets rid of the square root in the denominator. So the conjugate is 1 minus the square root of 2. And you do it top and bottom. Just focus on the denominator, its conjugate, but you got to multiply top and bottom by it because you can't multiply by anything except for 1, otherwise it will change the value of the fraction. So multiplying this, I get 6 times 1 is 6. 6 times negative square root of 2 is negative 6 square root of 2. All over. Now we do just like we did up here, double distribute. So 1 minus square root of 2 plus square root of 2, and then minus square root of 4. So 6 minus 6 square root of 2. The middle terms cancel each other out. They get rid of each other. They're opposites. And so I get 1 minus 2, which is negative 1. Ladies and gentlemen, even though this is the right answer, we don't leave negatives in the denominator. So the way to get rid of the negative in the denominator is just multiply it by negative 1 over negative 1. That's just a common practice. If you got that, it's still right. So you get negative 6 plus 6 square root of 2. All over 1, which you don't need to write. Are there any questions on that one? Okay, all right. Let's do number 8. This one looks very complicated, but if we kind of hold to our process, bring the numbers, multiply them together, bring the numbers together, etc., we can work it out. The difficulty with this one is they have different indexes. You can't just multiply these two together when they have different indexes. We've got to get a common index. So what I will do, I do spot on this one that the 4th root of 625, if you don't know that, that is equal to 5. That makes this problem a lot simpler if I recognize that this part, I do cube root of 40 times the 4th root of 625, leave those under, move it up a little bit. Okay, this is going to be equal to 5, and then I'm looking for a perfect cube that goes into 40, okay? Perfect cube that goes into 40. So what we'll do is, okay, they just ran away. So somebody was at the door, peeking in between the little spots and ran away. Okay, what perfect cube goes into 40? Well, 8 does. So then off that list, we get the cube root of 8 times the cube root of 5. Okay, so I just wanted to get a little bit of the numbers done. Now let's go back to the variables. This, watch up here, this is going to be 5 over 3 as an exponent. So I'm going to have m to the 5 over 3 power. This will be n to the 1 over 3 power. Over here, I already got rid of the 625. This will be m to the 6 over 4 power. And n to the 20 over 4 power. Now, when you have same bases multiplied together, you add exponents. So on the m's, I'm going to take 5/3, and I'm going to add to it 6/4 will reduce down to 3/2. So I'm going to add to it 3/2. And here, that 1/3 plus what is 20 over 4 reduced down to? 5. So now I have a 5 there. So I'm going to take care of the reducing. That will help with common denominators. Any questions before I move on from there again?
How did you get the cube root of 8 and cube root of 5 from 40?
Okay, so what I did was I wanted to look for a perfect cube in 40, and I knew that I wanted to think back to that list, you know, which of these numbers go into it. So I'm going to do 2 cubed, and right away I hit 8, and I know that 8 times 5 gives me 40. Okay, so I'm going to split it up because I know that is a perfect cube. Okay, so that's kind of my thought process. Look for those numbers. Now, this is a 2. This is a 5, I'm going to just put it out front here, times the cube root of 5 here. So you just put the knowns that are out of the radical together, one that's still under. Here, I need a common denominator. Well, this is 6 is the common denominator. So I'm going to multiply this by 2 over 2, that's 10. This by 3 over 3, that's 9. So it gives me 19 halves when I add together those fractions. I'm sorry, 19 sixths. 19 over 6. Common denominator 6. Here, I've already got this in mixed numbers, so I'm going to leave it. 5 1/3. I prefer mixed numbers on this, so. Yeah.
There's 2 m's.
Thanks. Let's put that to the n. Good. Good catch on that. Now, I still had somebody peeking in, so I was a little distracted. So. All right, now I've got a 10 here. Folks, here, what is this as a mixed number? It's 19 over 6. How many times does 6 go into 19? 3 times. So I'm going to have an m to the third that comes out, and I'm going to have left over a m to the 1/6 power. Right? This I still have the cube root of 5 here. This n to the 5th can come out because it's out of the radical, but I still need n to the 1/3. So do the mixed numbers, pull out the ones that are the integer parts of it, and leave the others underneath. Now this is a little tricky, this part. I've got a 6th root, a 3rd root, and a 3rd root. I can't make the 6th root into a 3rd root. Okay, I can't multiply this by something to get it down to a 3. But I can multiply this by 2 over 2 to make that a 6th root. And I can make this one 5 to the 1/3. I can multiply it by 2 over 2 to make it 2/6. So I'm just going to write that out a moment just so you see what I just did to get a common index. This is 5 to the 1/3, the 2/6 power times m to the 1/6 times n to the 2/6 power. These all now have the same index. So we're just going to list the ones that are out. And lastly, n to the 5th, this is the 6th root of the ones that are underneath. 5 squared is 25, 5 squared, m to the 1st, n squared for that. And that's my answer. I do want you to notice that I'm not using absolute value, okay? Even though we talked about that, you won't need to do that on the quiz. You won't have to worry about the absolute value parts of those that we talked about. All right, let me pause our video.